(26). We get, okay, so this is a little complicated. These are the ones that always get me. It's always a drag when I mess up on these, because they should be simple, but I find a way to kind of mess them up all the time. So I'm going to be really careful here, because I do see a negative here. I'm taking this quartic polynomial and I'm subtracting another quartic polynomial. Now, even though this guy looks bigger because he's got more terms, it doesn't mean that that's true. Just because he's got 3 terms, he has 5 terms, but it doesn't mean that this guy's any bigger than him. All right, they both shoot off to infinity in both directions. So, is there any? Oh yeah, there's no end behavior on this test. That'll be on the next one. Anyways, so we're going to make this addition, because that way I can kind of organize these. I can move them around the way that I want. If this is going to stay negative, then I have to do too much in my mind. So what I'm going to do is I'm going to distribute the negative sign to everyone. So I'm going to make this addition by making him negative. He'll become negative. He'll become positive. He'll become negative. And he'll become positive. All right. Now what I've done is I've turned this now into addition. So these guys can kind of move wherever I want. The 12 to the 12x to the 4th and negative 5x to the 4th can now combine. Now that's the highest degree that I have, so I'm going to do that first. All right, so I'm going to have 12 minus 5 is actually 7, and then I'm going to have x to the 4th. All right, so what I'm going to do, though, because there's so many of them, I'm going to cross them off. Okay, I just want to get them out of the way. Now, this guy has a negative 5x squared, but he does have an x to the 3rd, so it looks like this plus 7x to the 3rd will go. He's got no one to combine with. Okay, he was negative, though, so I almost missed that. Let's give him a negative sign. Now I've got a second and a second, so that's negative 5, that's a positive 3, that's negative 2x to the 2nd. Yeah, I took care of those guys. That is a negative 4x, and this is just 2, and that'll combine with the 9, so this guy won't combine with anybody. Okay, and then the 2 and the 9 is going to be 11. All right, I've taken care of all of my degrees. I'm at 4, 3, 2, 1, and then 0. 4, 3, 2, 1, and no x, so it's 0. All right, and that's our final answer. So I almost missed that guy. So watch out for just those little errors. I do those all the time. It drives me crazy. All right, so this one is now a 2 being multiplied to 3. So what I'm going to do is I showed you guys that this is so much better to make a little table when you have so many things. Okay. Now sometimes on the diagonal you can add those, but sometimes you can't. So what I'm going to do is I'm going to go x to the 3rd, negative 2x, and then this guy will be 3x squared minus 3x, and then plus 5. Okay, I'll just put the plus 5. And then this guy, there's nothing in that corner spot. All right, and we just treat it like a multiplication table, and we're just going to go ahead and multiply this. So 3x to the 2nd times x to the 3rd is just 3x to the 5th. So here you add the exponents. Here you do not. You just add the coefficients. When you multiply, you add the exponents. Moving across, this is going to become negative 3x to the 4th, and this will become positive 5x to the 3rd. Okay, cool. Now what I'm going to do is I'm going to add all of my this right here. This result is going to be just like this problem. I'm just going to add all of the like terms that I have. I might not have any. So far, I do not. Let's see. What is negative 2x times this guy? That's going to be negative 6x to the 3rd. Okay, this guy and that guy will combine. Okay, so that's cool. And then negative 2x times this guy is going to be a positive 6, and he'll be squared. He will not combine with anybody there. And then I've got a negative 10x, and he will not combine with anyone. So this means that my only like terms are this one and this one. So I'm going to combine these, and then everything else is just going to look like a string. Okay, I've got a 3x to the 5th power, putting in order of degrees. I've got minus 3x to the 4th. Those two added together will give me a negative 1x to the 3rd. And then I've got a plus 6x to the 2nd, and then I've got a minus 10x. All right, so doing this little chart, is a lot easier, I think, than doing it this way, foiling it. Okay, 'cause it's not really foil. Foil requires 2 and 2. This is 2 terms and 3 terms, and so it's not quite foil. So this, I think, is the best way to handle this, and it kind of just keeps all of your terms like separated and very sensible. Okay. All right, is x minus 6 a factor of this polynomial? And if so, write p of x as a factor of or as a factor of 2 factors. As a factor, I should say, as a product of 2 factors. All right, so does it go into even? If it goes in evenly, that means when I perform synthetic division, I'm going to get a 0 at the end of the rainbow. Okay. So what we do when we determine. Okay, now remember, this is the factor theorem, and in your notes, you're supposed to remember that you want to make this guy 0. You need a positive 6 to go in the window, and then what you do is you take all these terms and you just set them across. Now, notice, though, that 4, 3, 2, 1, 0, these guys all are in order, they are all descending, and there's no holes. If there's a hole, I'm going to have to put a 0 in, okay? So we have a coefficient of 1, we have negative 8, we have 16, we have negative 23, and then we have negative 6. Now, if it is a factor, I will get 0 at the end. Okay? So drop the 1. 6 times 1 is just 6. Add those two, negative 2. Then we get negative 12. That's 4. That's 24. And I get 1, and then I get a positive 6. So it looks like that's actually 0. Okay, so what do these numbers mean? It means, yes, it's a factor. Okay, but now it means that if I were to take this guy and divide it by this, I get this. Now, what is that? This guy, remember, if we started with this guy as x to the 4th, when I divide by x minus 6, he dropped a degree. Okay, he dropped a degree because that's what happens. Okay, if you took x squared and divide by x, you just get, he drops a degree. Okay, it's just x. So, anyways, he drops a degree. So, this means that x minus 6 times x to the 3rd minus 2x to the 2nd plus 4x plus 1. If I were to multiply these two, I get this. Okay, this equals p of x. Okay. All right. So if you, man, you guys are lucky. You guys know that they didn't have synthetic division. We had to do something called long division. It was dumb, super dumb. Synthetic division is super cool. What's cool is you get to use synthetic division in the next two as well. It's such a powerful technique. It's used all the time. Use synthetic division to divide this by that. Okay, so now they're just getting straight to the point. They're not asking whether or not it's a factor. They want to know, like, what is the result. Okay, so let's see. We got 9 goes in the window. 3, 2, 1, and 0. So it looks like we've got them all in order, and I don't have to put a 0 for anything. Let's see what we got. Got a 1, then that's a 9, and then that's a 1, that's a 9, that's a 4, and then that's a 36. So I end up with a positive 6. So this has a remainder. Okay. This makes it different. So now if I were to divide these guys, what I get is I get x to the 2nd power minus x to the 1st plus 4x to the 0, right? There's no x anymore. But I do have this remainder, and so you got to remember how to handle a remainder, and it works just like the old division algorithm did back in the 5th grade. And that is, you take the 6 and put it over what you were dividing by. Okay? Alright, there's just a neat little thing. This is just necessary so that if I were to take this guy and multiply to if I were to multiply it to here, I actually get that extra 6, which is what I needed to bring me to negative 30. Anyways, that's our answer. And finally, the last question. If I'm going to use the remainder theorem, okay, what you got to remember is that the remainder theorem allows you to plug in a number into here for a quick answer. Okay. Normally we would kind of use our calculator to do this, but what if you don't have a calculator? Now I know we all got our phones, but our phones don't do this stuff very easily either. Okay. So you want to, putting in negative 5 to the 4th power, if you're going to do that mentally, it might be kind of hard to do. So what you do is get out a scrap sheet of paper, and you can do this mentally if you put these guys. If you do this right, you can do synthetic division and actually find out what it would be putting negative 5 into this polynomial. Okay, so now we got negative 2, and then we've got positive 3, and then we went from x squared to, we are missing an x. Okay, so it looks like we're missing that x to the 1st power, so we do need a placeholder. I'm going to make that color there. That's very, very important, or else it doesn't work. It will not work right. So you need a placeholder for that. That's the only thing you got to remember with synthetic division. And do I put a positive 9 or do I put a negative 9? Okay, for a question like this, we put in a positive. For a question like this, you put in exactly as you see it. Do not switch the sign. Okay, so whatever this answer is right there, that's it. Okay, we just have to make sure that we do this properly. Drop the 1, multiply now, add that, negative 5, add that, that's 35, that's 38. Okay, negative 5 times 38. Okay, it's getting larger now. 190, and that's negative 190. Negative 190 plus 0 is negative 190. Times 5, it's going to be positive 0, 950. Alright, so add negative 1, and that's 949. Alright, that is our answer. Now, let's double check, okay, just because I don't trust myself. At 9:22 in the evening, drinking as much coffee as I have. So negative 5 to the 4th, minus 2, negative 5 to the 3rd, okay, plus 3, negative 5 to the 2nd, minus 1. Alright, told you. Alright, good luck on your final exam, everybody.